what I've got here is an update of the document that I put online. When anything in yellow is highlighted, I recommend that you watch and study as essential viewing. I talked about this a bit, so I'm not going to talk about it much today. Teaching writing as a process, not as a product. That was a kind of reinforcement of what I just did in the tutorial. I was talking about the process of writing, and I was being reflective about what I'd written, and then I was altering it, and then I was talking about how to make it, or the kinds of things I think about when I'm writing. This is an interesting book, should you wish to get it and read it, and I recommend. Composing is a process of listening to self. So this idea also, in terms of listening to self, is, I guess, central to this idea is the idea that when we compose, we listen to ourselves musically, logically, and critically. Is that the right direction for the melodic line? Should it keep descending, or should it ascend before descending, and so on? What are your inner dialogues? What are you questioning about what it is that you are hearing? What are you listening for when you are writing music, when you are composing, when you are thinking about, or when you are developing a project? An obvious macro plan of the direction of a time-based work, in other words, a composition, a music or sonic experience, is to understand what the component parts of the sound is doing. In other words, what the little bits, what the minor bits are doing when you're composing. Is tension building? Are there diversions contained within the sound? In other words, is there a counterpoint operating? Is there a bass line operating? When is it operating? Does it always have to operate? No. When does it come in? When does it come out? So when you write something and you've got an idea to write something, what I suggest is that you write a plan. You write a plan that says, line here, write down the three instruments. Flute starts here, joined by clarinet, and then both stop and marimba enter, or percussion part enters, with flute playing, and then all three do a short passage that lasts for 30 seconds. And then there's a duet between the bass clarinet and the marimba that set up a rhythmic thing that the flute plays over. Then all three interact by swapping phrases between the three, and then there's an outro or a conclusion. Hence, there's a linear plan. There's a plan there that you've got. Now, you might change that plan 1,000 times before you actually get to the end of what it is that you're talking about. So what I'm interested in is for you to understand the process that you go through in developing your music, how you plan it, how you realize it. Do you stick to the plan? What are the plans that you are making? And sometimes we start out thinking we are writing a particular idea, only to find out that we've arrived at a point where we are somewhere else. So we started writing something, and then we're in a position where we're actually writing something else. Did you notice the transition that you made into this something else, or did it go unnoticed? Are there many thoughts? All these and many thoughts may come to us during the process of writing a piece, sometimes to give you concentrated thoughts to, something to give concentrated thoughts to understand your process. And that's really, really important. Now, what we're talking about today is a particular kind of historically acknowledged mathematical process. This mathematical process is happened in a period of post-tonal music. And we all know, I guess, what post-tonal music is. That's the music happened after what's known as the common practice period, or tonal period. And musical set theory is a part of this. I guess part of this is also the 12-tone part. When Schoenberg introduced the idea of duodecaphony or 12-tone music. And following on from that, in the 60s and in the 70s, there's an idea that is mathematically brought to bear that kind of comes together with the ideas that came out around electronic music and around the sort of mathematical explosion of science as a result of the Second World War. There's a famous book called Music Since 1945. I'm not sure if you've read that book or if you've had that book as a kind of thing in your past educational experience. But in Music since 1945, since 1945, at the end of the Second World War, all these things came to fruition. A lot of electronic music obviously came out of sonar, radar, and submarine tracking, and bouncing sounds off the bottom of the sea, and so forth and so on, etc., etc., etc. But what we're dealing with today is musical set theory. And these guys here, Howard Hanson and Alan Forte, drawing on 12-tone theories of Milton Babbitt. Milton Babbitt was a well-known American composer. I think he might have taught at Juilliard, anyhow, well-known and 12-tone kind of guy, followed in the footsteps of Schoenberg. So the idea of set theory is a mathematical concept about organizing sets of numbers, quite simply put. The language of set theory can be looked at here. And I encourage you to explore all of these set theory music. Yeah, set theory music, for example, and to read all these little pop-ups, equivalency, forte numbers, and how the number system works, the identity of music, the interval class, the interval vector, permutations, etc., pitch class, so forth and so on. That's quite important to read all the dialogue and understand the nomenclature or the word identification ways in which set theory is described. But quite simply, here's the fundamental: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, T for 10, and E for 11. But there are 12 there, obviously, because 0 is 0. So there are 12 tones, and in post-tonal theory, identified is similar to identity in music. We're talking about universal algebra and mathematical terms that have to do with permutations and combinations of the way in which you can extract from these 12 tones groupings of 2, 3, I guess 4, 5, 6, and even 7. Although the main groupings are groupings around 3, and they're all these are numbered. For example, tetras, decas 2, tetras 3, quartils 4, I think. And so in the idea of hexatonic, six note series, or set, a 6-note set. How many 6-note sets are there in combining within this 12-note chromatic scale? How many sets of 3 are there within this 12-note? How many sets of 4? How many sets of 5, etc. So there's a number of things here which are described. We describe pitch. So obviously pitch is, we know exactly what pitch is, and that's not a secret. It's the tone of a sound as classified, yes, from, I guess these days, 448. In music, a pitch class, or PC, is a set of all pitches that are a whole number of octaves apart. So this is a pitch class of C, all Cs, yeah? So we have pitch class. Generally, this requires symmetry. For instance, inverting or augmenting a